Okay, we're going to go back and we're going to review our friend the quadratic function. So the quadratic function is really just a parabola. And if you remember from ninth grade, you can write a quadratic two ways. You can write it in the y equals ax squared plus bx plus c form, or, which is called standard form, or you can write it in its vertex form. Y equals a quantity x minus h squared plus k. Okay, so to review that, everything starts with the mother function. It's really called the parent function, but I like saying mother function better. So the mother function is y equals x squared. And if we were to put in points, it would look like such, right? 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And then we know that we have the reflection over on the other side. Now, I don't know if anybody ever told you this, but there's an easy way to graph a parabola. It's called its steps. So if I were to connect the dots of Mama, how we got that was, starting at the vertex, we had our bridge. We go over one spot and we go up 1 times the stretch. Where do I get the stretch from? The a value. And it's clearly represented whether you see it in vertex form or in standard form. Then to get to the next point, I still go over one value on the x, but I go up 3a. To get to the next point, I still go over one value on the x, and I go up 5 times a. So it's very easy to remember because this is an odd sequence. 1, 3, 5, and next one would be over 1 up 7a, over 1 up 9a. And that's all I did right here. I started at my vertex, I went over 1, and since the stretch here is the value of a, and a there is 1, I went up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3, 4, 5. And that's really the easiest way to graph a parabola. No math needed, just climb the staircase. All right, so let's make some babies from this mother function. So here we have y equals x squared, and it's written here in black. And I will do my best to connect the dots and make it look like a parabola. All right, so Mama's going to have a baby, and she's going to have a baby, and she's going to name him Blue, or her, or it. So this is x minus 3 squared minus 1. Now this is what you're working on in your stained glass projects. So basically, all I have to do is understand how movement occurs. And this is a review from Algebra 1. You should know that this is written in vertex form. So the vertex of this parabola is positive 3, negative 1. So I'll go over to positive 3, negative 1. There it is. Now, if you noticed, it's got no stretch. So I'm going to use that ladder that I had on the first page. That means I go over 1, up 1. I go over 1, up 1, 2, 3. I go over 1, up 1, 2, 3, 4, 5. And there is new baby parabola. And I will just take the mirror image. And that's how quickly it is to draw a parabola. Now if you notice, Mama moved 3 to the right, because this is what we were talking about, that if you are inside parentheses, you do the opposite. So Mama told baby to go negative 3, and it said, I'm going to go positive 3. 1, 2, 3. Every point on mother parabola moves 3 to the right. Then negative 1 is outside parentheses. That's the yes child. That's the y-axis. move down 1. So that's how baby blue was born. All right, now we're going to look at baby red. So baby red has the same exact vertex as baby blue. Opposite of -3 is +3, and we keep the k value of -1. But it's got a stretch of 2. So that means when we do our vertex, our stairs, over 1, up 1, this case A is 2, over 1, up 3 times A, which is 2, over 1, up 5 times A, which is 2. So in fact, I'm probably going to run out of room. So the vertex is the same, 3, -1, but I'm going to go over 1, up 2. And then I'm going to go over 1, up 6. 1, 2, 3, 4, 5, 6. And I can't go over 1, up 10 because I'm going to run out of room. So if I then do the mirror image of all of these, there is baby red. So baby red does look different than baby blue and mama, but that looks the same. I mean, that's the whole point, right? Everybody kind of looks like their mom and dad, but not exactly. So if you notice, what we're going to learn is baby red here has what we call a vertical stretch. It was stretched by 2. So it's 2 times taller than mom and baby blue. But that's for another section. That's in about 2 or 3 days. All right, so mama has yet another child. Mama has baby purple. Baby purple, well, baby purple's got a different vertex. So baby purple's vertex, let me get the right color. Baby purple's vertex is 3. Opposite of 3, -3 is 3, and then its y value is 2. So this guy has got a vertex at 1, 2, 3, up 2. But now it's got a stretch of -3. So we are going to do our stairs upside down. So instead of going up, the negative tells us to go down. So we will go over 1, down 1 times A, which in this case is a 3. We will go over 1, down 3 times 3, which would be 9. We're going to run out of room. And then over 1, down 5 times 3. So over 1, down 1, 2, 3. Over 1, down 1, 2, 3, 4, 5. And we can't get our, 6, 7, 8, 9, because 3 times 3 is 9, Mrs. Trulin. And we can't get in our 5 times 3, 15. We just run out of room. It's getting a little messy in here. Over 1, I'm going to just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I could have just added on 9, but I was already in the process. And then there is baby purple. So that is the quick way to draw any parabola that's in vertex form. No need to get out a calculator. In fact, it takes too much time to get out of a calculator. So what we want to remember are there are some certain words from Algebra 1 that we should remember. The axis of symmetry, right? The axis of symmetry is the line right down the middle of our parabolas. And if you remember, it's always the x value of the vertex. Of course, if it was a sideways parabola, it would be the y value, but you are not required to learn sideways parabolas anymore. So in all the cases, the kid's axis of symmetry would be x equals 3. Mama's axis of symmetry would be x equals 0. The roots are something we're going to do in the next unit, but the roots are where it crosses the x-axis. We're not worried about what those numbers are exactly right now. That's why you factor to find roots of equations. And then the turning point, well, that is just a fancy word for the vertex. So here, two babies have the same turning point, 3, -1. One baby has a turning point of 3, 2, and mama's turning point is 0, 0. So the last few things we want to talk about are domain, range, increasing, decreasing, and a y-intercept. And actually there's one more thing. So let's get ourselves a graph out here. So we've got a graph whose vertex is at -5, and since there is no k value, 0, right? It's plus 0 over here. So that means the y value is 0. So let's drag this puppy out and put its vertex over here at -5, 0. Notice the stretch is 2, so I went over 1 up 2. Then I'm going to go over 1 up 2 times 3, which is 6. 1, 2, 3, 4, 5, 6. So domain. Remember the domain are the x values. And we're going to look from our left side to our right side because we always move from left to right in math. So as I move over from the left, I notice that my green bar hits an arrowhead. Well, that means it's going on forever and ever. So the domain here has no boundary on the left. It's -infinity. And do we have a bound on the right? No, because I hit an arrowhead. So that's right. So the domain here is I can put any number I want in for x. Remember, the domain means what I can put in for x. Another way we could write this is all reals, but make sure you put the extra line on the back of the R to signify mathematical notation. So my y values, all I'm going to do is spin my bars. And once again, we move from smallest to largest. And in the y case, that means the smallest are on the bottom. I move up here. What's the first value I hit? Oh, I hit that dot. And the y value of that dot is 0. So my range starts at the number 0 because I do hit it. And then on the top, my bar hits, once again, arrowheads. So that means my range is unlimited. My y values will range from a low of 0 to a high of infinity. Now for increasing and decreasing, we have our little hiker. Once again, increasing and decreasing, we are talking about what x values make the graph either increase or decrease. So our little hiker, if we're going from left to right, our hiker is going down as we move from left to right, right? This x value is some value way up here, and then this x value is way up there, and then this x value is right there, and this x value is right there. So this hiker is actually going down from -infinity to the x value of -5. This hiker will be decreasing. Now I know there's a great debate because when I was in school, we wrote it as from -infinity to -5, and we wrote it as a rounded bracket because we were always taught that once you hit the bottom, you are neither increasing nor decreasing. Likewise, if you're at an apex, you're neither increasing nor decreasing. But that has changed, and they want you to include -5. Both ways are still accepted on the regions because it's a great debate. We'll talk about it more in class. Okay, so now what about the hiker? Where is the hiker increasing? Well, the hiker is increasing now from -5 to +infinity. And you can see the great debate because -5 can't be in both the decreasing and the increasing interval at the same time. But we're neither here nor there at this point. We'll leave that for Mr. Rude in calculus. The y-intercept, we know that ad nauseum. I don't want to say it anymore. You should have learned this. Means put x in as a 0. And when we put x in as a 0 here, though we cannot visually see the y-intercept, we can make it out to be 2 times 5 squared. So in this case, my y-intercept is 50.